Okay, so in this first one, they're asking us which figures are squares. So basically on this one, it should be pretty straightforward, like figure B is a square. Which ones are parallelograms? Well, C is the shape of a parallelogram. And which ones are rectangles? Well, A looks like a rectangle. So if you were to go through like this and check it, you would unfortunately find out that that is not totally correct. So even though we've identified correctly which shape looks like which, this does look like a square, this does look like a parallelogram, and this one does look like a rectangle. There's kind of a nested idea here. So squares are things that have four equal sides. So if you don't have four equal sides, then you are not a square. So for example, this guy is not a square. However, all you need to be a rectangle is you have to have two sets of equal sides. I believe that's true. You might need to have 90-degree angles as well. Let me check that real quick. Okay, yeah, four straight sides and four right angles. There we go. Okay, so as long as you have four right angles, you are a rectangle. So this guy is not a rectangle because it does not have four right angles. So if I asked what shape is this, if somebody said it's a rectangle, they're not incorrect. So this one, figure B, is a rectangle as well. Figure C is not a rectangle. Parallelograms, I believe a parallelogram just needs to have two sets of parallel sides. It doesn't matter what the angles are, as long as you have two sets of parallel sides, you are a parallelogram. So this one has two sets of parallel sides. This one has two sets of parallel sides. I believe all of these should be parallelograms. Okay, this one has us trying to solve a few things. So let's go through and see what we can label on here, first of all. They're going to give us some information here, such as Jn is Jn is 2x plus 7. 2x plus 7. Ln is 6x minus 9. So Ln is 6x minus 9. Angle NLK is 37. So that's down here. And that's all they give us. Okay, so first of all, this is a rectangle, so we know that we have parallel sides, which means that we know that alternate interior angles should be the same. So if this one is 37, we know that this guy up on the top left should also be 37 up here. If this is a rectangle, then these are 90-degree angles in the corner, which means that we would need another, what would that be? Another 40 or 53 would get us to 90 in that corner, which means that we also need 53 over here. What else do we have to say? So we know that. It's a rectangle, and we've got these diagonal lines. I think we should be able to just say that these corners would also be the same. Like that would be 37, and that would be 53. That would be 37, and that would be 53. Right, because if this is a rectangle, then this diagonal line is no different than that diagonal line. It's just going from one corner to the next. So I should be able to like flip this shape over and it should look exactly the same. So it looks like we've got a bunch of isosceles triangles, is what it appears to me. One of our isosceles triangles is this one, which is 53, 53, and if I wanted to label last side, well, they have to add up to 180. I've got 106 right now, so I would need another 74. And we know that this length here is 2x plus 7, which means that this one should be 2x plus 7. If I pull out that other shape that we have, we've got kind of the longer, skinnier triangle, which has 37 on the top and bottom. That is 74, so we'd have another 106 right here. And we've got 6x minus 9 for that length. Okay, so might have gone overkill, not quite sure. Haven't looked at what they actually want from us, but those are all the things that we would be able to kind of quickly surmise based off that picture. Okay, so they want km. They want from here to here. Well, that should be the same exact length as this length. This length was 2x plus 7 and 6x minus 9, so that's 8 x's right there, and minus 2 overall. If we have minus 9 plus 7, it would be minus 2 overall. So I would call that 8x minus 2. Oh, they don't want an x in there. Figure out what it is. We'll work on that in a moment. So we have to solve for x there. Okay. I think what they want us to do, because we've done trigonometry. We can use trigonometry to do it, but that's not what this lesson's about. That's probably not how we should do it. What else do they want? They want angle JNM. JNM. Okay, well, that one's already figured out. That's like this piece. It's just on the opposite side, right? It's on that part. Okay, but that should be the same. Should also be 106. 106 there. So just trying to think about how do we get km? How do we get that whole length? We know that it should be 8x minus 2. But how are we going to figure out what the x is the question. We don't know anything else. We don't know the side length, so we can't use Pythagorean theorem. I'm going to hop over into an example real quick and just try to get a head start on what direction they want to go, because there's different ways you could figure this out, but I want to make sure that we're doing it in the way that this lesson is getting on about. So, oh, okay. That makes sense. So they're just saying that these two pieces should be equal to each other. That makes sense, right? If we're doing diagonal lines, where these two diagonal lines should meet, it should just meet in the middle of this rectangle. So it should cut this whole line in half, which means that this piece and that piece should be the same. That will be a much quicker way of solving this. Good. I'm glad I checked that. Okay, so we are going to say that 2x plus 7 should be the same thing as 6x minus 9. And we'll go through and solve for x there. So I'm going to subtract 2x from both sides. So I get 7 equals 4x minus 9. And I'm going to add 9 to both sides. So I get 16 equals 4x. That tells me that x has to be equal to 4. So 4 times 4 is 16. Now, if that whole length was going to be, I think it was 8x minus 2 when I put those two pieces together. Well, this is going to be 8 times 4 minus 2. So we'll have 32 minus 2, or 30 altogether. Let's give that a try. Okay, good. So this is just another classifying one again. So this one, I want to keep in mind like the markings on here. So for example, this one is shown looking like it's a rectangle with 4 90-degree angles, but they haven't marked them. So unless they mark them specifically, you can't trust in how the picture's drawn. Now we can trust that these two are parallel. They are parallel and congruent. As long as you have two lines that are parallel and congruent, kind of forces the other ones to be parallel and congruent. So this one should be a parallelogram. This guy has two 90-degree angles. These angles match. Well, if we already have 180 and we need 360 altogether because it's a quadrilateral, then these two have to be 90-degree angles also. Just because they didn't call them 90 doesn't mean that we can't kind of figure out that they ought to be. So that fits the definition of a rectangle. Oh, sorry, we've got quadrilateral for all four of these. They're all four-sided shapes. This one fits the definition of a rectangle. Now, does it fit the definition of a parallelogram? I would think so, as long as we have 90-degree angles here, like here and here. That is going to make these two sides parallel, like the bottom and the top. If you just kind of imagine that shape, it's kind of like a backwards C or something, kind of makes it so that they have to be parallel. So I would say we know this is a parallelogram. And then finally on this one, it doesn't tell us anything about the angles in the corners. It does tell us we have parallel sides, and it does tell us we have congruent segments that are broken in half. Well, kind of based off the last question we just saw, where we saw that if you have a rectangle and you connect the corners, you're going to end up right in the middle of those two diagonals. You're going to cut them in half into congruent pieces. I would say that this is going to meet all three definitions as well. Could be something off here, though. There's lots of different ways to answer this. So lots of ways to answer it incorrectly, but turns out that nothing went wrong there. Okay, so you're just kind of looking at the symbols, trying to piece together what conclusions you can come to based off all the symbols you're seeing. Okay, for the rhombus below, find the measures of angle 1, 2, 3, and 4. Okay, well, first of all, let's just double check that we all know their definition of what a rhombus is. Sneaky way of me saying. Okay, rhombuses. Parallelogram with opposite equal acute angles, opposite equal obtuse angles, and four equal sides. Opposite equal acute, opposite equal obtuse sides. Any parallelogram with equal sides. Okay. What is a parallelogram without equal sides? I'm not sure I'm seeing how a parallelogram and a rhombus are any different from each other. Oh, okay. I get what they mean by equal. They mean all of them have to be equal. So rhombuses have four equal sides. Every side is the same, whereas a parallelogram can have different size pairs. Okay, that makes more sense. Okay, so rhombuses have four equal sides. So they want to say, what are all the angles we're going to get? Okay, well, let's draw this out. I'm going to draw it kind of a different angle. I'm going to kind of put it like this. Just kind of rotated it a little bit. And what I'm going to say is that, where's that 47 going to show up? In my picture, it would be like this one. So if that's 47, the alternate interior angle should be here at 47 as well. What else can we say? If those are all equal sides, it's a good question. What else can we say about this? We know that all four sides are equal. We've got one of the angles. We know the alternate interior angle should be the same. So that one should be 47 degrees. What else can we say? I'm trying to think. These ones don't have to be 90 because you can basically a rhombus is just going to be a square. Like if you took like a cardboard box and you started like folding it or like pushing it over so that it kind of like fell on its side, you would get you could get increasingly flat sides. Like you could flatten it until it was like perfectly flat along the ground. And when you did that, the length of it would be like twice as long as whatever you started with at the bottom. Right? I'm going to fold it down onto the ground. Trying to think of what that will do for our angles. So we'll always have a total of 360 degrees on the inside of these four angles. But is there anything else we can say about them? So what would this look like at this point? We would have diagonal. We'd have alternate interior angles. Just trying to think, does each corner need to add up to 90? I don't think they do, because this corner is getting smaller. This one's getting closer to 0. This one's getting closer to 180. I don't think I can say anything about the pair of angles here. Let's jump in the example again. Let's get a head start on this one. Okay, so they are saying that we should have the same amount on either side of that. Yeah, that makes sense. We should be cutting the shape directly in half. So if these sides are all the same length and we're going from one corner to the other, these two pieces should be kind of symmetrical. Like we can think of this diagonal line as like a mirror that should make mirror images. Okay, I'm okay with that reasoning. So if this one's 47 degrees, that one should be 47. Basically, all four of these should be 47. So 1, 2, this one, and this one, they should all be 47. Okay, that gives us a good start. So if they are all 47, at least those ones so far, I'll draw it the way they have drawn it now. Okay, if we have 47, 47, 47, 47, well, altogether there we have, what is that, 94, another 94, so we have 188. We need the whole thing to be 360, because that is what we have on the inside of a quadrilateral. So 360 minus 188 will be 212. What do we get? 12, 172, I think. Okay, so amongst these four angles, the top two and the bottom two, we should have 172. So if I take 172 and divide it by 4, I should get what each of those are worth. Okay, 160 divided by 4 is 40. So this should be like 43. Let's see. Okay, good. Find the lengths of sides, slopes, tell us what shape it is. Okay. Okay, hopefully if you see find the length of a side, your brain kind of goes quickly to the Pythagorean theorem. That's how we always find the length of a line. That line is at any kind of diagonal, and it's always found using the Pythagorean theorem. So they want the length of WZ, so WZ. So we're going to need to use a right triangle that looks like this to get the length of WZ. Well, what are the coordinates here? W in the, if I want to figure out this distance, this is its x distance, this is its y distance. Then the x distance should be like from here to here. Well, we're going from -6 to -1. So those are just 5 apart. And in the y direction, we're going from -2 to +6. So those are a total of 8 apart. Because One of them's negative, one of them's a positive. Right, so negative 6 to positive 2 would be 8 apart. And if we want to figure out this length, WZ, that line right there, well, we're going to have to use a squared plus b squared equals c squared. We're going to say 5 squared and 8 squared equals WZ squared. That's 25 and 64. Which come together to make 89. Which means that WZ by itself is the square root of 89. Side adjacent to WC. So adjacent means right next to. I mean, there's two adjacent sides and the length of a side adjacent. So they want either one of these. So let's do ZY up top there. Do the same exact thing. So we'd make a right triangle. And we would say that the distance in the x direction, we go from -1 to 7. So they're 8 apart. And we go from 1 to 6. So those are 5 apart. Well, looks like we got the same thing, 5 and 8 again. So that is just going to be the same exact thing. We're going to get the same exact answer. You get the square root of 89. And the slope of WZ. Well, WC, we want our rise over our run. So our rise is 8. Our run is 5. So 8 over 5. Slope of this one. Well, in this one, our rise, we're actually going down. So our rise is our y value. So that would be -5 over 8. We're going down 5 over 8. Parts A and B, we can conclude what? Well, I think we can conclude that this is a square. We've got these sides are the same. If I was to do the bottom one, I think if we get, what's this? 2 down to 7, so that's 5, 6 to 2, that's 8. 1, 2, 3, 4, 5, and 8 again. So all 4 sides are the same length. That makes you a square. Squares are also types of rectangles. Squares are also types of rhombuses. So let's give that a try. Okay. Okay, some more classifying stuff. So let's see what we got. Squares have 4 right angles, yes. Parallelograms don't. Trapezoids don't. One pair of parallel sides. I think that is the definition of a trapezoid. A trapezoid looks something like this. You've got a pair of parallel sides, and then you've got a pair of non-parallel sides that would eventually cross over at some point if you let them. So that would be a trapezoid, would be only one pair. 2 pairs of parallel sides is a parallelogram. That also works for a square. And all sides being congruent, I think is only the definition of a square. I don't think that's the definition of any of these other ones. Okay, last one. So let's kind of look at our I made originally. So we had squares, we have rectangles, we have parallelograms. Well, let's do rhombuses first. We have rhombuses where all 4 sides are the same. And we have parallelograms where we have 2 pairs of matching sides. Okay, so this is a square. These would both be rectangles. These would all be parallelograms. And a rhombus needs 4 equal sides. So I think these two would both be considered rhombuses. Okay, so it says every quadrilateral is a rhombus. No, so this one, rectangles, standard parallelograms, those are not rhombuses. Those do not have 4 equal sides, so we can say false on that one. Every rectangle is a quadrilateral. Yes, every rectangle does have 4 sides. No problem to that definition. So we can say true there. Every parallelogram is a quadrilateral. So every parallelogram has 4 sides. Yeah, sounds good to me. Every rhombus with 4 right angles is a square. Well, a rhombus has 4 equal sides, and if you had 4 right angles, that would make you a square. So I would say only the first one looked false to me. Okay, so that was it for Wednesday, where we kind of combined quite a few different lessons: rectangles, rhombi, and squares, and trapezoids all into one kind of big lessons there. Okay, so that is it. So I will upload that one onto Canvas as well for you. You can find that under the homework page for that assignment.